Sir.
Dear delegates, we are commencing our invited talk. Now I request Dr. P. Shah Sir, Devchand College, Arjunnagar, to chair the session. Thank you, sir. This technical session is being graced by Speaker Professor R. Kamble sir. Now I request Dr. A. Ramteke sir to introduce the chairperson and the honorable speaker of technical session.
Good morning, all of you. So, all the participants gathered here. The second day of today's national seminar on future perspective and innovative trends in chemical sciences. So, we are in technical session first of this 2 days national seminar. We have two great scientists. One is the Professor R. Kamble sir, and second one is Lokesh Shastri sir. For these technical sessions, we have a chairperson for the first technical session, third technical session, and first invited talk, Professor Dr. P. Shah sir, who is the vice principal of this institution. So I have brief introduce this chairperson of this invited talk, Professor Dr. P. Shah sir, who is completed MSc degree in Shivaji University, DCP in Shivaji University Kolhapur, MPhil in process control simulation and perturbations analysis, Shivaji University Kolhapur, PhD in design of SMPS using fuzzy logic, Shivaji University Kolhapur. Sir having 28 years of teaching as well as a research experience. Sir having 13 years PG teaching experience. Sir completed 1 orientation and 3 refresher courses at various places. Sir now working as a head of Department of Electronics. Sir worked as an accuracy coordinator from 2009 to 2017. Sir successfully taking a responsibility from this institution like the administrative assistant as a vice principal from 2010. Sir, a short-term training completed 12. Sir, also work as a sir has a various. It's a dynamic person and it's having various angles. So, sir, organizing NSS camps 4. Contributions of university administrations, LIC, VC nominee, subject experts, member of board of studies, member of 48-3A, this committee, electronics of Shivaji University Kolhapur. 15 international research paper and 3 national research paper published in various journals. Sir presented the paper in conferences 30, attended 80. Chapter in book is 1. Research excel is research guide. 1 page is awarded and 3 are working. So chairpersons, resource persons for various different levels and different colleges across the India, like 8. E-note materials is 43. It's a big number, and PPT is 32. So sir awarded 2 times. That is 2 awards to his credit. So with this brief introductions, I welcome you, sir, as a chairperson of this technical session. Thank you. Thank you.
Thank you, sir. I would like to request Professor R. Kamble sir to give his invited talk on topic heterocycles.
Now I would like to invite Dr. P. Shah sir to introduce the resource person, Dr. R. Kamble sir.
Welcome to all of you. Good morning. I am here to introduce today's speaker, Professor Dr. Ravindra R. Kamble, Professor of Organic Chemistry, Department of Studies in Chemistry, Karnataka University, Dharwad. He has completed MSc Organic Chemistry first class with distinction in 1997 from Arjunnagar University. He has supervised the MSc projects more than 50. His topic for PhD is reactions, ring transformations and fluorescence properties of some signon derivatives into 2002. He has supervised 10 PhD students. It's old. Until 2 and presently guiding 8 PhD students. He has more than 80 publications in international and national journals of high repute. He has written 2 chapters in books. He is working as a reviewer of many international journals of Elsewhere, Springer, Wiley, Taylor and Francis Publishing Groups, etc. He is having international fellowships, Indo-Hungarian Exchange Program 2012, University of Durban, Devchand, Hungary. Raman Postdoctoral Fellowship, USA. He has completed 3 research projects. He is having teaching experience from 2014 and he is having many administrative assignments. He has worked as nodal officer, data completion of NIRF, served as director planning monitoring and evaluation board, Dharwad University, chief coordinator UGC University with potential for excellence program in Dharwad University. He is working as coordinator USA in Dharwad University, member academic council Dharwad University, member finance committee in Karnataka University Dharwad. He has served as director students welfare in Dharwad, member of board of appointment, board of studies, board of examination of various universities with state and outside state. He has elected as EC member KU PGTA and now serving as president from 2019. I think this is old biodata. He is having more than this experience in various fields. Today he is going to talk on heterocycles in medicinal and material chemistry. And now I request Professor Dr. R. Kamble to deliver his lecture.
Do we have one? No? So good morning all of you. So principal of this college and vice principal. Sandeep Sable, who is mainly responsible for my travel from Dharwad to Arjunnagar, Devchand College. Dr. Avinash, who was always coordinating with us in regard to the preparations of this conference. Mrs. Sable Madam, the staff and students of wonderful Devchand College. So my place is very much here only. I am from Belgaum district, Arjunnagar, and my fraternal and she stays nearby this place. So whenever since I was a kid, I used to move from here to another place, and I used to always see one bus board that is from Nippani to Devchand College. So since from my childhood I know about the Devchand College, that there is a Devchand College exists somewhere here. But I never had seen this college. And my relatives who are in the near vicinity of this area, they used to tell me about the Devchand College. Devchand College, which is affiliated to Shivaji University, is also a very good college. And since from many years, I think these people have started the PG courses. So they have a PG courses probably earlier in the social sciences and languages, and now they even have started the MSc courses also. So this is really a good old college. In 1960, this college is established, and it has grown, and really I can see that this is one of the affiliated college of Kolhapur University, and also the college which is granted in college. I'm very happy to be a part of this conference. So, what I planned was, of course, this is not an invited lecture where the students can have a take-home message and they can start with their own work. But in what all the different kinds of fields, the kind of research, especially with regard to this chemistry, a chemist can go into what all the fields. I've taken the examples from my own research labs, and if you can understand that, really good, or otherwise if you can have the idea and if it triggers your mind that you can do something in your professional career, because I heard that here you have got a MSc in organic chemistry, which made my work even simpler. So I will be speaking on the introscience and medicinal chemistry, and next slide. Shall I operate up? Yes, you can give it to me. I can operate. Yeah. So, will you give it to me here? Yes. So the contents, as I told, I have divided my work into two. This lecture, medically important heterocycles and heterocyclic compounds in medical chemistry. Since the medicinal compounds, usually we all know that they contain usually the heterocyclic compounds, and this is for the information students, because I learned that UG and PG students will also be there, and these are the common heterocycles that we always find among the drugs. Well, this medicinal chemistry is a discipline which is at the intersection of chemistry, pharmacology, which involves the synthesis, development of new chemical entities that are of medicinal and pharmaceutical uses. It is an interdisciplinary science which involves organic chemistry, phytochemistry, pharmacology, toxicology, molecular biology, all these, even computational chemistry, because nowadays all of you are hearing this artificial intelligence. Now, people are earlier, the drug discovery pipeline involves 14 years, because if a drug lead compound had come, it used to take around 10 to 14 years for converting it into a drug molecule in the market. But now it has been reduced due to the artificial intelligence, and in 8 years, 8 to 9 months, a drug will come from the lab to the market. So this has the artificial intelligence has reduced the time required for the drug discovery pipeline. Okay. So if you go back to the history of this medicinal chemistry, a wide range of natural products, they might be from plants or animals, like lizard blood, all these have been reported. Ambergris, bat lips, they have been used from animal sources. So this ambergris, what I am mentioning here, this ambergris is from, it is produced in the stomach of a whale, and this cost for 1 kg, it is almost like 1 crore rupees. So this is being used in a fragrance industry and even in a medicinal industry. And metal sources like stone drugs, heavy metals like palladium, mercury, copper, all these were used as a medicines. They are called as stone drugs. So some of them were toxic also, and Greeks used them as a pharmacon for both medicinal products and toxic compounds. So the therapeutic properties were described by Greeks and they have been nicely recorded. And coming back to India, we have got Ayurveda, which is also a well recorded information that we have. Of course, the only thing with here is there is a synergistic effect of Ayurvedic medicines, where many of the components will be responsible for the cure of a disease. So when we come to the drug discovery, what happens in the case of drugs? Initial step of involves the identification of new active compound, often called as a hit or lead, and these are identified by screening of the molecules of synthetic or natural sources. And these hits can also come from synthetic sources, and comparing to the historical compounds, compound collections to obtain the compounds having analogous structure, and then they carry out the structure relationship, and chemical modifications can improve. So chemical modifications, they are also required for the exact location of a drug to go into a particular place in the receptor. So let us move on to the heterocycles, and my field where I have chosen is mesoionic compound. I work in this sidnone field where just now Shah sir mentioned I worked in a sidnone field in my PG, in my PhD, where these are the sidnone derivatives which are 5-membered mesoionic compounds which cannot be represented either by covalent structures or by ionic structures. That's why they are called as the mesoionic compounds, and this is were discovered in University of Sydney. That's why the name came as sidnone. And then similar kind of analogs were synthesized and they in a Munich University which were discovered, they are called as Munchnov. And recently when I started preparing for this lecture, I came to know that there is one more heterocycle that has been reported, that is the Montrealone, which was reported in the year 2008 by name Montrealone, and it was reported from McGill University, Montreal, Canada. So that's why the name came as a Montrealone. So these are the structures of heterocycle sidnone with the ionic structure. Because I told you the definition, it is a 5-membered heterocycle which cannot be represented either by a covalent or a ionic structure. So these are the structures of which can be synthesized by a glycine and nitrosation of glycine, and then reaction with acetic anhydride gives this sidnone. So what is the importance of this sidnone? They can be ring transformed into the other heterocycles which are equally stable. Okay, this sidnone, even though it is ionic, this is also stable at a room temperature, and they can be ring transformed into pyrazoles, or they can be ring transformed into phenylindazole or some other pyrazole or tetrazine derivative. So they can easily be ring transformed into some other heterocycles of medicinal importance. Okay, these. So in our lab, what we did was we converted them into a initially oxidizole and then converted them into a triazole. And what our contribution is, there was one compound which was formed which was unknown, and we could identify what is the structure, and that too it was in a major proportion. This was used to be formed, and we identified this by doing the extra-crystal structure. Similarly, we converted this sidnone into a 1,3-oxidizole, which was converted into 1,2,3-triazole, and under the influence of this mesyl chloride, we introduced one very good leaving group which was reacted further with all these kinds of components, and when the coumarin was introduced, it showed a very good anti-cancer property. And this anti-cancer activity was done at National Cancer Institute Bethesda in US, and almost few of the compounds they have shown from 50 to 99% anti-cancer property, which was done at USA. So this is another interesting reaction that we did, where we had planned to convert this sidnone into here we have converted this into its corresponding hydrazone, and then we wanted, of course, it was then converted into pyrazole over here, and then we wanted to introduce orthophil diamine over here to get this. This was the expected compound. This we wanted to have this compound as our product, but interestingly we got an entirely different kind of compound. We got a compound which it was expected, and we got obtained compound was entirely a different compound, and this was conferred by a single crystal X-ray study, and we even gave the mechanism how this is converted, and all that conversion we gave a mechanism, and this was published in ACS. Now let us come to coumarins. Of course, Dr. Shastri is here, who is an expert in coumarin chemistry, and here these coumarins they have a lot of applications. Like they have all these applications with pharmacological application. They have been used in drug discovery, self-healing, and sensors, fingerprint, and all these ink and various kinds of applications are there for coumarins. And even from our lab, we have synthesized so many number of coumarin derivatives. And this is one such kind of a reaction that we did, where we introduced the acetyl group at this fourth position of sidnone, and then reacted with converted into a corresponding hydrazone, and reacted that with the coumarin with COCH2Br, and got this hydrazone derivative over here at a fourth position of sidnone, and then which was reacted, of course, with directly this plus this we got this three component reaction directly we can get this compound, and this has shown a very good antidiabetic activity. So similarly, we could get this compound in which the triazole, this is from sidnone, and we reacted that with the these two compounds where the acetyl bromide and this in presence of a DMF to get a compound like this, which was also active against lung cancer, breast cancer, HeLa and myelogenous cancer cell lines. And this is another reaction in which this is a click chemistry reaction in which we converted 4-bromomethyl coumarin with sodium azide to form this alkyne, and this azide and this alkyne, they can react together to form where 1,2,3 triazole was converted, and this is click chemistry. And last year only this kind of click chemistry, which was reported by Sharpless and Meldal and Bertozzi, it received a Nobel Prize. And this kind of it's a kind of click chemistry. And next, let us move on to the quinoline. Quinoline derivatives, they also have a lot of medicinal applications like anti-cancer activity, strong binder. So this is such kind of quinoline moieties have received very strong binders and oncogenic RAS inhibitors. So you all know, because it is of course a textbook chemistry where the quinolines can be synthesized by Scraps method. And here we designed this kind of a molecule by doing a SAR study, that is structure activity relations studies, in which we designed these kind of quinolines where if this quinoline, which is a pharmacophore and substituted at 6th position, will confer a high potency, and this CH2 is a special determiner, and this is a linker. This triazole, this acts as a linker. And after designing such kind of compound, we even did a DNA docking, because DNA is a primary target for number of cancer compounds, anti-cancer compounds, and because of that we did docking studies using computers. It is a in silico computation study, and when we did docking, and we got a very good C-score values for this, and this prompted us to synthesize the molecules, and we synthesized these molecules, and out of this we got about 6H and 6-9, which have shown almost 92 to 97% of anti-cancer activity against breast cancer cell line and melanoma cell lines. So which were once again done at the National Cancer Institute at Texas, USA. So this is another kind of compound, because we got these two compounds from the industry. So industry people, they gave us these compounds. These are actually anxiolytic agents which are antidepressants. We tried to introduce this with the quinoline derivative, and when we introduced, they also exhibited the anxiolytic properties, where antidepressants means we actually tested them on mouse models where the depressant activity of a mouse was reduced to these kind of compounds. So even this was confirmed by X-ray analysis. So then let us move on to these triazoles. The triazoles are also very important moieties, where these triazoles also, like a fluconazole, itraconazole, rabuconazole, oroconazole, they all of them, they exhibit a lot of biological activity, and we did this, and when we saw the all these activities like exhibiting various kinds of pharmacological properties, we also tried to convert these sidnone derivatives into oxidizole, and this oxidizole was reacted with this formamide to get triazole, and triazole here NH, at this NH we introduced the alkyne moiety, and we got this acetylenic dipolarified. Okay, so in this alkyne, and we had a triazole with us, and initially we synthesized copper microcrystals, where all these copper nanoparticles were embedded on this, and how this was synthesized, that I will show you later. Okay, so we had this kind of approach where earlier in earlier slide you saw that copper sulfate was used, and now we use copper microcrystals to convert these alkynes into a triazoles, and this was found to be a very good antifungal hit, where this also showed the antifungal property. This is another example of conversion of triazole, the azide into a 1,2,3 triazole, which has exhibited antitubercular. So now let us look at this quinoline moiety, where with the help of this click chemistry, we approached this kind of compound, and when we got this compound which exhibited antitubercular and antifungal activity. So how we prepare these copper nanoparticles? Just now I showed you copper nanoparticles and copper microcrystals, where we use a solid jaggery, which is of course it is a jaggery carbohydrate which contains which is basically a sucrose, which has got both the glucose as well as the fructose moiety, which undergoes hydrolysis, and this is a reducing sugar, which reduces the, we made a mixture of these, and then we reduced the copper sulfate, and we got these brown color wonderful copper oxide nanoparticles, which is actually a green synthetic approach. And this we used for the conversion of alkynes into azides, and we got this. So this which exhibits the anti-cancer and wound healing. Okay. So now let us move on to this heterocyclic compounds in a material chemistry. So this was our medicinal chemistry approach. And now when we look on to this material chemistry, what is this material chemistry? It is a highly interdisciplinary science which involves the use of chemistry for creation, characterization and application of materials with interesting and potential useful physical or chemical characteristics. Okay. So the substances of interest include inorganic, organic, polymeric and hybrid metals, and thus material chemistry incorporates solid state chemistry, nanoscience and polymer. So hence material chemistry is central to the development of technology and the global economy. So synthetic materials have played a vital role in improving the standard of living and the quality of human life. And it is essential for solving the greatest challenges of our time, from sustainable energy storage and environmental challenges to the development of quantum devices and quantum communication. So hence, we synthesized novel heterocyclic-based sensitizers, anti-counterfeiting, fluorescent molecules and nanoparticles or nanocomposites from greener approaches. So, why we need a dye-sensitized solar cells? The increasing energy demand inferior the burning of fossil fuels, which has resulted in serious environmental issues. So, which is impelling the request and investigations about clean and renewable energy sources for development of sustainable society. So, among the renewable energy sources such as solar, geothermal, that is coal, wind and water, the solar energy is considered as most promising one. A solar cell photovoltaic cell is an electric device made up of semiconductor material that converts the solar energy into electricity by the photovoltaic effect. And it has, from 1990s, the DSCC has gained considerable attention because the solar cells, they have been reported since from 1950s, where the Bell Laboratory initially designed these solar cells with the help of silicon solar cells. Okay. And these DSCC, which have been reported by Grazel in 1991 for the energy conversion, that is a harvesting of a light, solar light, and which involves low cost, easy processing and environmentally benign property. So Grazel was the first who designed this kind of a solar cell, and this solar cell is a third generation photovoltaic device. So when we look into the how the solar cells have been designed. So the first generation solar cells, they included the polycrystalline silicon solar cells and monocrystalline silicon solar cells. Of course, monocrystalline solar cells, they exhibit more efficiency. So the second generation thin film solar cells, they have got amorphous silicon solar cells and cadmium telluride, copper indium gallium, diselenide solar cells and gallium arsenic solar cells. Of course, the lifetime is copper mild. That's why the third generation solar cells have come, which are hybrid solar cells. They all have got, of course, a nanocrystal based, polymer based, concentration solar cells and perovskite. Of course, perovskite solar cells exhibit more efficiency, but their stability is very less. Whereas dye-sensitive solar cells, they exhibit comparatively more stability. So these are the types of solar cells. So what is the principle? The working principle of this solar cell is in this solar cell, sunlight is absorbed by molecular dye. So if a dye is taken, which has got a valence band as well as conduction, or a highly occupied molecular orbital or a valence lowest unoccupied molecular orbital. So the molecular dyes which act as sensitizers here, they inject electron after the light is incident on the dye. They excite, and one of the electrons from a dye will be injected into a conduction band of a semiconductor. So what is a semiconductor here? They take a DiO as a semiconductor, zinc oxide as a semiconductor, or the CDS, cadmium sulfide as a semiconductor, where this dye will push its electron into the conduction band of the photoanode, and where the electron will go into the FTO, and then some work is done, that is in terms of a light glow or some the current flow will be identified, and then it will go into the counter electron. And from counter electron, what happens here is the electron will once again go back into the, there will be a electrolyte which is present here, and this electrolyte which will take up electron from this counter electrode, and it will be this iodide anion will be an electrolyte, it will take up 2 electrons and becomes 3 iodide anions. And this 3 iodide anions once again go back to the dye, which is here oxidized dye, which has lost its electron, and it gives away 2 electrons to it, and it itself will be converted into I3 minus, and dye will be regenerated here. So this dye will once again is ready for taking the next amount of the solar energy. So like this, we can push the solar energy into the dye, where the dye will give away electron to the conduction band of a n-type semiconductor, and then this process will continue. Okay, so this is the working principle of dye sensitized solar cells. Okay, a lot of investigation has been done with regard to the dye sensitized solar cells, including photoelectrodes, dye sensitizers, redox electrolytes, counter electrodes, and all that. And TiO2 is one such semiconductor device, and even the zinc oxide, as I told you earlier, zinc oxide can also be a very good sensitizer, which can be used as a sensitizer. And there is a property required for the sensitizer also. Sensitizer means it is an organic molecule which has got a d pi a, means there must be a donor, there must be a linker, that is a pi linker, and there must be an acceptor. Okay. Donor, linker, and acceptor. These are the 3 properties which should be there with the sensitizer, which will be further attached to a semiconductor like this. A semiconductor where a semiconductor will hold on the dye. Okay. So these are the requirement, and the efficiency of these donor, linker are good. Then only the electron injection into the semiconductor will be very good. Okay. So what are the donor groups? They consist of phenothiazine, indolin, triphenylamine, coumarin, carbazole, etc. All these can act as a donor groups. So here, this is the work done by me in the US, where we use this phenothiazine, and we introduced the large alkyl moiety here, that to reduce the agglomeration of a dye on the semiconductor device. And then by Wilson-Hack strategy, we introduced aldehyde over here, and then we introduced a linker group which will link on the semiconductor, that is a TiO2. And then these spectra indicates the UV and the fluorescence spectra of compound which is in the region of more than 600, almost like 600. This is required for fluorescence, where if it absorbs at this region, then only it will act as a very good dye. Okay. Then this is a kind of dye that what we synthesize, and then these are the photoelectric, where the current density is current density versus voltage we plotted, and if this area, that is the fill factor, if it is more, if this area is more, the efficiency will more. And even we did electrochemical properties like cyclic photometry, and we saw the oxidation and reduction potentials, and they are favorable. And even with that, we calculated the energy difference between the highly occupied molecular orbital and lowest unoccupied molecular orbital. So the efficiency was found to be, in this case, it was 2.15%. Okay. So then this was with the TiO2 nanoparticles we used. And then we tried, because we had one collaborator who was working on a CDS nanowires, and we made use of his expertise, and we made use of a CDS as a semiconductor device, and which used to accept the electrons from the dye, and we made these CDS coated FTO, and then the CDS compact layer was introduced, and then CDS nanowires were introduced on this, and these are the same images which indicate this is CDS compact, this is CDS coated, and this is CDS compact, and this is the CDS nanowires which we got the same images from these. Okay. So this is the introduction of dye on the CDS nanowires, and after soaking for almost like 24 hours, we could get these dye coated CDS nanowires for 12 hours. For 12 hours, and all these CDS nanowires have been imbibed with the dye. Then we constructed a device, and the device structure was found to be FTO, compact CDS nanowires, again dye, electrolyte, and platinum. So this is how the sunlight will be incident on the dye embedded on the CDS nanowires, and we got for these kinds of different molecules, where we have this as a linker here. This is a linker, and even this is a rhodamine triacetic acid, and this is a pyridine as a linker we got, and on the phenothiazine dye, and we could see that with this PDA, where this linker is a rhodamine, we got CDS nanowires also exhibit the sensitization property, but the efficiency was 0.1, and when we introduce our dye, the efficiency was found, because efficiency is nothing but a ratio between the power output by power input. Okay, so we saw that there is a enhanced power output almost like a 2 times enhanced in presence of these die molecules, and from 0.101 to almost double the efficiency was observed with these 2 die molecules. Okay. So when we compare the rhodamine and this pyridine, okay, for the few of the papers they showed that the heterocycles can also, heterocycles like 6 member heterocycle pyridine can also be because what is the requirement for a linker is there must be a presence of a COH which will link on the semiconductor, which will make it to link on the semiconductor. And here we introduced the linker without any such kind of electron withdrawing group, but pyridine itself acts as electron withdrawing. Through these lone pair of electrons, it links itself on the semiconductor, and we for the first time tried with these molecules, and we could get more amount of efficiency with the pyridine rather than the already reported rhodamine 3 acetic acid. So even we introduced here, what we had done is we introduced a large alkyl group over here, and in this case we tried to introduce a heterocycle itself on this kind of a molecule, and this is a cyanoacrylic acid as a linker over here we use, and these are the 4 different molecules like PPR, PCTR, PPC and PCTC. These were used as a dye, and we tried to get their efficiency, and almost the efficiency was double or tripled in these cases. So the efficiency of these dye-sensitive solar cell, where the power conversion efficiency was found to be more in this case, and this was published in a Physica, which is from elsewhere. So these are the phenothiazines, and here in the earlier cases, what we had to do was we had to introduce a linker group purposefully so that it should link on the semiconductor. But here what we did, we took a molecule because we took advantage of preparing our Sidnone derivative and introduced, which was previously introduced with a COH. Okay, so we took this and converted it into a triazole, and then this kind of through this oxidization we got a triazole, and then on the NH2 this functionality we used to convert it to a simple skip base using such kind of moieties, and we checked their efficiency, and it was found to be almost 3 times, and the intrinsic property of this COH was checked here, and we got almost 3 times increased efficiency for these kind of dye. And this is also a similar kind where for these sinones at para positions we can get a acetyl group, and this was converted into a chalcone, which is a very good electron linker group as well as electron donating group we introduced, and these are the donors. These are the donors where we introduced on these dye, because the sensitizer require a donor and a linker and a acceptor. All these are required, and we introduced all these three things, and then we got the efficiency checked, and the efficiency was found to be almost 3 times to that of CDS. And these are also metal-free fluorescent pyridine dyes which are anchored on CDS nanowires. It's a very simple strategy where triphenyl group, a simple triphenyl group was used and pyridine was used, where pyridine at a different position. Here it is at the 2nd position, here it is a 4th position, and here it is also once again it is a 3rd position mistakenly. And here also we could get almost like more than 2 to 4 times increased efficiency was observed with these. Okay. So these are highly fluorescent molecules that we got, where when a 3 component reaction we did it, and we got such kind of a dye where this nitrile and this NH2 acts as a linker on the semiconductor, and we use a CDS nanowires once again. We got a very good efficiency with these kinds of molecules, where very simple strategy of a 3 component reaction was done to get these kind of dye sensitizers. So now, so where all these dye solar cells have been used? So this is a 200 meter square STI DSCC panel which is installed in Newcastle in Australia, the first commercial DSCC module, where these are the organic molecules, because earlier the efficiency was good with the ruthenium dyes. Silicon, of course, still the people are using silicon, their efficiency is really good, and lifetime is also good with the silicon, and it's available, but the cost of production of all those silicon is more. And here, because we need to get silicon from SiO2 and then polycrystalline and monocrystalline silicon is to be converted, and all that process requires a lot of processes which are not only the time consuming and lot of money is required in that, and synthesis of dye is comparatively lesser, and this has been established in Newcastle in Australia, where the first commercial DSC model. And these are the DSC models for outdoor applications which have been done in, by various kinds of agencies in Australia as well as in Japan. So the solar cells have been introduced in various kinds of the mobile phones, and even with the bags they have applied there, they absorb the solar energy into them and they store the energy, because the capacitor is also attached to that, and such kind of devices with solar cells have been they have been introduced into the market. So now let us move on to the another important area which we are working. A counterfeit, that is a duplicate, is an item that uses someone else's trademark. Say for example, you might have heard with regard to this Fair and Lovely cream, where Fair and Lovely cream will come with the same name, same kind of a name will come. Okay, so that is, some of the people they will be duplicating, and if there is a hologram, then the duplication will be reduced. So such anti-counterfeiting means making nakli. Counterfeiting means nakli, making a duplicate item. Okay, so how to identify it? Identify means we need to have one, either a sticker which is made of by the original company. Okay, so such kind of anti-counterfeiting holograms can be synthesized using the fluorescent molecules, and for that we need to have a organic moiety, which must be a fluorescent moiety. Okay, so in view of this, we synthesized a fluorescent moiety with this kind of a 3-compound strategy, and this was highly fluorescent, especially the 4s compound in this. One we coded as 4s, that was highly fluorescent, and we synthesized, of course it is a coumarin derivative, and this is a mechanism of conversion, and because this is so much fluorescent that the UV is found to be 327 to 432, and its photoluminescence was from 430 to 480 nanometer, which and one of the compound, that is 4Si, as I told you, has got a highly fluorescent nature, and this is a anti-counterfeiting ink formulation. How this, with the help of the synthesized compound, how we can make a ink formulation? For this, they make use of slurry of compound with the ethanol and glycerol mixture in a 85 to 15 ratio, and to that they add a surfactant, that is sodium dodecyl sulfonate, and then they add polydimethyl siloxane. This was added, and then this is the binder. This is the binder, and then the transparent ink was created by ultrasonically processing for 20 minutes, and we got a anti-counterfeiting ink formulated. And how? So this ink, which can be a solidified powder, and here how they develop a latent fingerprint on this. So on any surface, fingerprint is deposited, and on this, the powder that embedded with our synthesized compound was dusted with us, and then on UV light we can see it, so that developed fingerprint can be easily observed. Okay. So this is how we can create a latent fingerprint on any surface. Similarly, yeah. So this is after observation of this fingerprint, what we can see. See here on the daylight at different. See the fingerprint taken on a leather. This is on the leaf. This is on a CD. This on a different on a wood and all that. We took the same fingerprint, and these are the ridges and furrows of a fingerprint. And this region, that is a yellow color marked region. So these were cross-section observation we have done for this, and then so with this compound 4S, we could get a very good impression of all this. So stating that this compound can be very good reagent for the creation of a latent fingerprint. Okay. So this fingerprint that we got, these are the level 1 and level 2 kind of a fingerprint, where anybody can make a impression of these. But level 3 and level 4, where if we make more resolution, there are various kinds of places like the bifurcations in the lines of a fingerprint, hooks, bifurcations, islands, cross covers, regions, scars and dots. All these will be there, and these cannot be duplicated. Level 1, level 2 anybody can do, but these cannot be cheated. These cannot be done. And even this fluorescent compound that can be even used for the identification of this, and even this can also be resolved very easily. So this is about aging. This is about lifetime of this. So almost like 270 days. The impression that we have taken will remain and nothing will happen with this. So this is screen extending to the same work. We made a screen printing. That is because the hologram that we see on the product, the same kind of hologram can be synthesized where luminescent ink, when it is taken on a printed mesh. This is the printed mesh with lots of holes here. So with this same kind of structure will be holes, and on this mesh is taken and pasted on a surface, and this will be squeezed with the compound. That compound that we have prepared in, as I explained it to you, and then we get an impression of this, and which can be seen only in the UV light. So that if anybody making any culprit, if he is a culprit and if he is making any counterfeiting, that is duplicating, we can easily identify it. Such kind of holograms can be synthesized, which can be observed in the UV light. Whether, and by this we can identify whether it is a duplicate product or the actual product. Okay, so this is taken on a different kind, like a wood and various surfaces. We can take such kind of impressions. So these are the fluorescent hydrogels. Even we can make a molds of this using the same kind of a compound, and this mixing with the cellulose nitrate, and then the sulfuric acid and heating on a water bath. We can get the slurry of this with the synthesized fluorescent compound, so that a mold can be synthesized, prepared, and we can have a mold of our own choice, a different choice. Kinds of molds you can synthesize, which can glow upon irradiation in the UV light. So this kind of a molding, the hydrogels, can have various applications in soft robotics, sensing, information encoding, and information encryption. Okay. So even in nanometals field, we have, because nanotechnology, where the nanoparticles have various kinds of properties, because a molecule which is cut into the nano size will have a different kind of properties, and the properties will entirely change, and which can be used in a drug delivery, bioimaging, cancer treatment, fluorescent biology labels, and wound healing, tissue engineering. All these can be done with the help of the nano particles. Okay. So how these nanoparticles are been synthesized? Because we have done some green synthesis of novel. So how the earlier reports, they have been, the nanoparticles have been designed with the help of the microorganisms, various parts of flower, leaf, and fruit seeds, where the extract should have a very good reducing electrode potential, where the plant extract will be taken, and this nanoparticle synthesis can be done, and they can be used in various, after characterization, they can be used in either catalysis, wastewater treatment, drug delivery, many things, where these nanoparticles can have various applications. Okay. So during COVID, many people were using kiwi fruit, and here, which prompted us to make use of a kiwi fruit, because kiwi fruit has got a lot of ascorbic acid. So that we almost like around 5 to 6% of juice contains ascorbic acid, and which can reduce the copper very easily. Of course, copper and zinc can be easily reduced. Copper, zinc, and silver can easily be reduced, and we got a copper oxide solution, which was converted into copper nanoparticles by adding this simple kiwi fruit juice. This is a mechanism of conversion of copper sulfate into nanoparticles. And this is FSM image of this copper nanoparticle, which is globular shaped, and this is characteristic pattern of copper oxide nanoparticles. And the application that we did was the cytotoxicity, where in all these the circle cells, where these were introduced into a cancer cells, and we found that there is blebbing, means the chromatin of nucleus has come out. This is a normal untreated, and this is doxorubicin, which is a anti-cancer molecule, and these are the copper oxide nanoparticles which we introduced, and the cytotoxicity of copper oxide nanoparticle is clearly visible, which will exhibit its toxic effect on the cancer cells. So this is also another example of chitosan silver nanocomposite waste, where the same kind of strategy was used, where instead of that we made use of a mixture of chitosan and the acetic acid, and a mixture of all these three were taken, and through that we added and we got a chitosan silver nano composite we got, and this was used. This is a schematic representation, and this was also used as this is of course a SEM image, and this was used as a reducing agent where in presence of sodium borohydride, which can act as a reducing agent, of course, and it catalyzes the reducing. This is chemical property of chitosan silver nano composite, where the nitro group can easily be reduced. So this is a ordinary nitrophenol, and when we add a sodium borohydride and 4-nitrophenol, there will be a bathochromic shift, and hence you can see very easily that enhanced UV. And then after some time, when we add sodium borohydride, this chitosan silver nanoparticle, there is another band which is appearing for 4-aminophenol. So indicating that conversion of a nitrophenol into aminophenol. So even we made use of these nanocomposites for the anti-cancer properties, where these clear portions indicate that they exhibit oral and lung cancer saline, where the inhibition of the or anti-proliferative activity of these nanocomposites can be easily understood. So this is the IC50 value of the synthesized these nanocomposites. This is antioxidant activity, where antioxidant activity is nothing but free radicals, reducing the free radicals, abstracting the free radicals. Free radicals are responsible for the creation of cancer cells in the body, and here the free radical absorption can be done with these, and these exhibited the antioxidant properties. So this is once again a copper oxide nanoparticle where we synthesized, and where this here what we did was we made use of these copper oxide nanoparticles, because in the earlier example they used copper sulfate as a catalyst for conversion of the alkyne and azide into a 1,2,3 triazole, and we even gave a mechanism where the copper into which forms an intermediate lone pair, the pi electrons of this alkyne and a metal cycle is formed, and at the end there will be conversion of this into a triazole. We even proposed a mechanism for this. Okay. So these copper nanoparticles, where as I told you, they also act as the breast cancer, MD, and cervical cancer, or where they inhibited the clear lines they indicate. This is untreated, where this first square is untreated, and these clear squares they indicate that the anti-cancer activity has taken place. And even we made, this is a mechanism where the exposure to the copper oxide nanoparticle, cell clipping and chromatin will come out, and this apoptosis will occur, because it is a programmed cell death where the anti-cancer property can easily be observed and the dead cell. So the programmed cell death can occur with the help of these exposure to the copper oxide nanoparticle. And wound healing activity, we even made use of these copper oxide nanoparticle for the wound healing activity, where the skin burns almost are making 1,80,000 fatalities annually. So because of this, the problem is, negative aspect of wound healing is the lack of donor skin for the burns. So because of this, what the nanoparticles have been used in the wound healing problem. Okay. So in view of this, what we did, we took sample cells like animal cells, that is L94 cell line we chose, and this was exposed to the copper oxide nanoparticle that we synthesized, and we evaluated them for 0 hours, 6 hours, 12 hours and 24 hours. And so this is the area which indicates about the wound, and as we go on looking at the wound, size of the wound is receded due to the introduction of copper nanoparticle. This is because the anti-inflammatory activity will be triggered with the help of the nanoparticles, copper oxide nanoparticles, and hence there will be the initiation of the growth of cell rather than normal cell. Rather than normal cell, it took almost 36%, almost 100% normal cell wound healing will act on this with the help of this copper oxide. So this is another schematic representation of the wound healing activity by copper oxide nanoparticles. With this, I finish my talk, and And if you have got any doubts, please raise your voice so that I can, if I am able to answer, I will. Thank you.
Thank you very much, Professor R. Kamble sir, for your valuable presentation. Now the session is open for discussion.